Our first step is to find our y-intercepts, so we're going to multiply -2, -2 and 3. Recall please that when you have a bracket squared, you have two of those brackets, so -2 and -2 will occur, so twice. When we multiply that together we get 12, so a y-intercept of 12. Our x-intercepts are at 2 and -3. If you remember or can recall that a power of 2 on a bracket means that our x-intercept actually also refers to a turning point. So this x equals 2 will actually be a turning point. If you don't remember that to start off with, then we can look at that using the sign diagram. So those are our x-intercepts. Because we know that there's no negative in front of our x's, we have a positive cubic. Sign diagram, we're putting in our -3 and 2. Because we're a positive cubic, we're going to start down the bottom and end up the top. So starting down the bottom and then ending up the top. Now I've put this like this because although I touch my x-axis at 2, I do not cross over it. So I've got a positive area at the top and negative down the bottom, and I'm 0 at each of these lines. Now, if you can't recall that, you can use a sign diagram to find out. So I'm going to substitute in an x value between -3 and 2, so 0. And when I do that, I get out y equals to 12. So y equals to 12 is positive 12, so it's up the top. I can do the same for each of the other ones. So I end up with a positive for a value greater than 2, so 3, gives me positive 6. And then something less than 3, -3, sorry, will give me a negative. So graphing this, we're going to go through at -3 and 2, so we're -3 and 2 on our axes. Again, we're not interested in where this turning point out in the middle of nowhere is, so we're not going to actually put a value to this. We are, however, crossing at positive 12, so we need to put in our labels on our axes. So graphically, this is what the function looks like, and that's as detailed as your graph needs to be at this stage.